Hey everyone, welcome to the math review packet answers. Here are your answers for the 4 questions on Hardy-Weinberg. If you need to at this point, you are certainly welcome to pause the video, check your answers. If you have all the information correct, you can stop this video and move on to the next section. Otherwise, stay tuned for the solutions on how these got worked out. So here's how you solve for the Hardy-Weinberg calculations. For number 1, we are given that white wool is dominant over black wool, and then in a sample of 900 sheep, only 9 are black. You always start with your recessive allele because that is your Q squared. So Q squared is equal to 9 out of 900, which is equal to 0.01. Now, from this information, it's asking us to calculate the allele frequencies, so they're just asking us to solve for P and for Q. Now Q is easy because we've already got our Q squared set up. To solve for Q, we would just take the square root of our Q squared. So Q is equal to 0.1. And if we know Q, we can plug it into the equation. P plus Q is equal to 1. And subtract this from 1 to solve for P. So P is going to be equal to 0.9. Okay, let's take a look at number 2. It's telling us that for a population, 38% of the individuals are recessive homozygous for certain traits. They want us to calculate the homozygous dominant and heterozygous individuals, but here's the thing, they don't want the homozygous and heterozygous frequencies themselves. They want us to take into account the fact that the population has 14,500 people. So when we calculate these frequencies, we will need to multiply that by the number of people to find out how many actual people in the population would have these traits. So always start with your recessive allele, which is, or start with the recessive genotype, because we know, based on that phenotype, we know exactly what their genotype will be. Q squared is equal to 0.38, 38% of the population. So to find out Q and P, I start with my Q by taking the square root of my Q squared, which means that Q is equal to 0.616. And to solve for P, I'm going to do 1 minus this value. So P is equal to 0.3836. Now that I know Q and P, I can solve for P squared and my heterozygous, which is 2PQ. Keep in mind, though, that once we get these allele frequencies, we're going to need to multiply both numbers by 14,500 because they want to know the number of people, not the frequencies of these genotypes. So P squared is going to be equal to 0.3836, and I'm just going to square that value, which is 0.1471. That's the frequency of the allele. And now to find out how many people are in this population, what I'm going to do is I'll multiply it by 14,500. This is the number of people themselves. So the number of people that are homozygous dominant are going to be 2133. Then for my heterozygous, I'm going to do 2 times P times Q, which is 0.4726. Again, times 14,500 people, and I get the number of heterozygotes to be 6,852. Roughly, I rounded there. So for number 3, we're looking at another example of Hardy-Weinberg. And in this case, the information that we are starting with is that the homozygous condition, homozygous recessive condition, is lethal, and the frequency is 1 in a million. So since we're starting with the homozygous recessive frequency, then that is our Q squared, and it is 1 in a million, which is 10 to the 6th. And they're asking me to calculate the number of individuals in a town having a population of 14,000 that could be expected to carry this allele. So since they're carriers, we are looking for the heterozygotes, and we're not looking for the frequency of the heterozygotes. When we get this answer, we're going to multiply it by 14,000 to see how many individuals. So first we need to calculate what that frequency of the recessive allele is. and then divide that by, or get the square root of that, I'm sorry, to calculate the value of P. So I have my Q squared is 1 in a million, and I just converted that into a decimal, and now I'm going to take the square root so Q is equal to 0.001, and if Q is equal to 0.001, I need to solve for P by subtracting 1, which is 0.999, and now to calculate the frequency of the heterozygotes, I multiply 2 times P times Q, and I get a very small number, 0.000998001. I'm keeping the decimals just because the number is so small. And now I'm going to multiply the frequency, so I'm going to multiply it by 14,000 to find out how many individuals would actually carry this. So the number of people would be around 14. For the last problem, we are given that there are 2 Siamese and 3 Persian cats. So since there are 10 cats, that means that there are a total of 20 alleles on that population. And of those in that population, only one individual carries the little f, the recessive allele for the ears. So 1 out of 20 is going to be equal to Q, and P is going to be equal to 19 out of 20. So the frequency of the recessive allele is 0.05, and the frequency of the dominant allele is 0.95.